In exercise 2314, we're going to try to make some amines using reductive amination. Now the big idea that we learned in the previous video, the big picture of a reductive amination is that you're turning an aldehyde or a ketone into an amine. And you do that first by creating an imine, and then by reducing that so that it becomes an amine. Now, if all this sounds completely foreign, I strongly encourage you to go back and watch that previous video. That explains how this reaction works. So what we're going to do is we're going to take each of these amines that they give us, they're sort of giving us this product, and we're going to think backwards. What ketone or aldehyde could we make that from? Wherever the nitrogen is bonded, that carbon could turn into a carbonyl. Then we'll just make sure to add an amine, acid catalyst, and sodium cyanoborohydride, and we'll be good. All right, let's start with this first one. They give us this amine here, and how could we make this from doing a reductive amination? Well, there are really two ways, and they're asking us for two ways. Take a bond between a carbon and a nitrogen and break it. Draw the two pieces separately. So on the left, here we have this piece, and on the right, we have this piece. And they were connected like this, so we separate these into two pieces. On the half that does not have the nitrogen, and the bond where the nitrogen was attached, create a carbonyl. So make a double bond there. Actually, I'll do this in purple so that you can see the difference, what I'm adding on. So create a double bond there to an oxygen. And then there's still a hydrogen here. I'll just draw it in to make it clear. That's an aldehyde. For the nitrogen, where the nitrogen was attached to the other half of the molecule, draw in a hydrogen. And so this is what we needed, an aldehyde or a ketone and an amine. You can take the aldehyde or the ketone. You can treat it with three things. First, your amine. You want that in a mixture with catalytic acid and sodium cyanoborohydride, NaBH3CN. And all of that together will give you this product. So that's one way that you could make this. And what happens first is you create the imine with these reagents, and then you reduce the double bond between the carbon and the nitrogen to a single bond with the sodium cyanoborohydride, like we discussed in the previous video. So that's one possible way to make this molecule. They were asking for two ways. So if we go back to our original molecule, when we were looking at the product we wanted to make, our first step was to break a bond between a carbon and the nitrogen. Well, we broke the one on the left, but there was no reason why it had to be that one. It could have also been the one on the right. And if you break that bond, then take the two pieces on either side of it, redraw them separately, so these are those two pieces separated. And here, where they're in the molecule that does not have a nitrogen, make the bond that you broke a carbonyl. Add a double bond there, and put an oxygen at the end of it. And there's a hydrogen. I'll just draw that in so that it's clear that's an aldehyde. For the molecule that has the nitrogen in it, where you broke the bond, put a hydrogen. And so that's what you need, an amine and a carbonyl. You can take your aldehyde or your ketone. We're going to treat that with the standard recipe for doing reductive amination. It's going to be a mixture, first, of the amine that you have, and in that you want an acid catalyst with sodium cyanoborohydride, NaBH3CN. The acid catalyst and the amine, in the presence of the aldehyde, will create an imine. That'll have a double bond between the carbon and the nitrogen. So this nitrogen will replace the oxygen of the aldehyde. And then the sodium cyanoborohydride, that weak reducing agent, will reduce the number of bonds to the nitrogen from 2 to 1, so that you would end up with this product here. So either way, you can use reductive amination to create this reagent, this product that they're asking about. Okay, let's try the same thing with B. So we can take the molecule we have, and what we want to do is to break one of the bonds between a nitrogen and a carbon. Let's start with this one on the left. Actually, start with that one on the left. You could have the piece on the left there. So now once you break that, draw the two pieces separately. You could have the piece on the left, and you could have the piece on the right. So these two are sort of together, and then you break the bond, you draw the two pieces separately. Okay. In the part of the molecule that doesn't have the nitrogen anymore, in the bond that you broke, turn that into a carbonyl. So add a double bond and an oxygen at the end of it. And if there's room, fill in the hydrogen for the aldehyde. On the molecule that does have the nitrogen, in the bond that you broke, put a hydrogen at the end of it. And those are the two pieces that you would need to make this molecule. So if you take the aldehyde or the ketone, we can do reductive amination to turn it into the amine. We'd treat it with the amine that we have, an acid catalyst, and sodium cyanoborohydride, NaBH3CN. And that would give us the product that we wanted. Now notice we broke the carbon molecule on the bond between the nitrogen and the carbon on the left, but there are two other bonds between carbon and nitrogen. Notice that if we broke the bond between the carbon and nitrogen on the right, we'd really end up with the same thing, because the molecule is symmetrical on the left and right sides. So if we were thinking of a different synthesis we could use to make that would be if we broke the bond between the carbon and the nitrogen going up. Now, when you break those bonds, draw the two pieces separately. So we have the piece on top, the piece on the bottom. You break those. In the molecule that doesn't have a nitrogen in it, make the bond that you broke a double bond and put an oxygen at the end of it. So you make a carbonyl. Oops. Now this has two hydrogens on it. That's formaldehyde, the smallest aldehyde. On the part of the molecule that had the nitrogen, make the bond that you broke go to a hydrogen. And those are the pieces you would need to do reductive amination. You could take the aldehyde or the ketone and the amine, and all you'd have to do is put it in the presence of an acid catalyst and sodium cyanoborohydride, NaBH3CN. The aldehyde, acid catalyst, and amine would react, in this case, to give you an enamine, and then you can reduce that using this weak reducing agent, sodium cyanoborohydride, and after that step you would get your amine. So reductive amination. So those are two ways of creating that molecule using reductive amination. Okay, let's try C. So in C, we have an amine, and so now you want to think, okay, I can make this amine using reductive amination. All I have to do is choose a bond between the nitrogen and a carbon and break it. So we could break that bond there, for example. And when you break it, you have these two pieces. The carbon that does not have the nitrogen, the carbon that was bonded to the nitrogen, on that one, put a double bond to an oxygen, a carbonyl. And here, if there's room, you might fill in the hydrogen to make sure it's an aldehyde. You make sure it's clear it's an aldehyde. On the nitrogen, where you had the bond to the carbon, put a hydrogen. And that would be what you would need. All you'd have your aldehyde and your amine. You would just have to dunk this molecule into an acid catalyst, and make sure you have sodium cyanoborohydride there, a weak reducing agent, NaBH3CN. And that would give you your product. Now, you should also be able to draw this molecule in a more normal-looking way. Whenever you want to do that, to turn a cyclic molecule into a straight chain, I would encourage you to number it. Now, here you're not numbering it to name it, so you don't have to worry about all of the niceties of the directions that you should number it in. You just want to keep track of stuff. Here we have a 6-carbon chain, so you can redraw that 1, 2, 3, 4, 5, 6. If we number this, on carbon number 1, we have our aldehyde. On carbon number 5, we have our amine. So, that would be the molecule that we could use. So if we took this molecule, and you'll notice that it has two of the functional groups that we need in order to do a reductive amination. It has the aldehyde and the amine in one molecule, so this is an intramolecular reductive amination. And we use acid catalyst, then the amine will react with the aldehyde to create an imine, and then we just reduce that with a weak reducing agent like sodium cyanoborohydride. Now that's one way that you can make this molecule. But when we did this, the first thing we started out by doing was breaking a bond between a nitrogen and a carbon. But there's no reason why we should do that up and to the left. We could just as easily do that down. And that gives us another way of making this molecule. You could break that bond going down, and in that case, you can erase that. The carbon that was in that bond, on that carbon, draw a carbonyl. And the nitrogen, on the nitrogen, add a bond to a hydrogen. And so here we have a ketone and an amine, and if these come together in the presence of an acid catalyst and a weak reducing agent like sodium cyanoborohydride, NaBH3CN, then first they'll come together in the presence of the acid catalyst to give you an imine, I-M-I-N-E, and then the weak reducing agent will reduce that to your amine, which would be your product. Now, this kind of looks funky, and so you'd want to be able to redraw it. Here I'm going to number this chain just to keep track of stuff. We have 6 carbons again, so we could have 1, 2, 3, 4, 5, 6. And so we can number this. On carbon number 2, we have a carbonyl. And on carbon number 6, we have an amine. So this is another molecule that would give us this same amine. If we took this molecule here and we dunked it in catalytic acid and sodium cyanoborohydride, it would give us this cyclic amine. So those are 2 ways that we can create that cyclic amine using reductive amination. All right, let's try it with D. Now in D, first thing we're going to do is draw our molecule. And then we're going to break a bond between a carbon and a nitrogen. Let's start with this one on the left. So if you break that bond, let's erase it. On the carbon that was in that bond, draw a carbonyl. Double bond to an oxygen, and if there's room, fill in the hydrogen there. On the nitrogen in that bond, draw a hydrogen. And that gives you both your aldehyde and your amine that you need in order to make that molecule through a reductive amination. All you'd need is catalytic acid and sodium cyanoborohydride, NaBH3CN. In the presence of catalytic acid, the aldehyde and the amine would turn into an imine, and then this weak reducing agent would reduce the imine into an amine and give us our product. So that's one way that we can make this product. And I might even draw this a little bit more conventionally. We can redraw this, and you would have you'd still have the ring on the left, but maybe here, instead of these carbons that you have up here, I notice we need 1, 2, 3, 4 of them. You'd have 1, 2. You could have 3 and 4. And then on that fourth, you would have your aldehyde. So that might be a more conventional way of drawing this structure up here. They're really the same. Either way, if you dunk that molecule in catalytic acid and sodium cyanoborohydride, it'll give you the product that you wanted. Now, when we did that, when we designed this reductive amination, we broke the bond in the top left. There was no reason we had to choose that specific one. Notice that this molecule is symmetrical on the left and right sides, so whether we broke it on the top left or the top right, that's the same thing. But there is one other place that's different where we could have broken it, and that's going down. If we had broken that bond, then we would have had on the carbon, where that bond was, you would put a carbonyl, and on the nitrogen, add a hydrogen. And that would have given us both our amine and our ketone if you dunk that molecule into a solution that has catalytic acid and sodium cyanoborohydride, NaBH3CN, it would have given you, or it would give you, the amine that we wanted. So the amine and the ketone that we have in the presence of catalytic acid would turn into an imine, and then this weak reducing agent, sodium cyanoborohydride, would turn that into an amine. Okay, one last one. Let's try E. So here, you see an amine and you say, I can make that from a ketone or an aldehyde using reductive amination. You just have to figure out what aldehyde or ketone you need. To do that, take a bond between the nitrogen and a carbon and break it. I'm going to try breaking this one on the top left. Let's start with that one. So if you take this molecule and you break that bond, on the carbon where that bond was, draw a carbonyl. And if there's room, add the hydrogen in. And on the nitrogen, add a hydrogen. So this molecule has both an aldehyde and an amine on it. Those two can come together and create an imine if in the presence of catalytic acid, and then that imine can be reduced to an amine by using sodium cyanoborohydride, NaBH3CN. So if you had that molecule in the presence of those reagents, you would get the product that you wanted. Another option would be if you took the original molecule and instead of breaking the bond on the top left, you broke the bond on the top right. So in that case, you'd erase that bond. On the carbon that was in that bond, you would draw a carbonyl. And on the nitrogen, you'd draw a bond to a hydrogen. So here, we'd have these two molecules. Now, these are not part of the same chain, same carbon chain. So the way you'd write this is you'd have the aldehyde or the ketone, and then you'd add the amine to a solution of catalytic acid and a weak reducing agent like sodium cyanoborohydride, NaBH3CN. In the presence of catalytic acid, the amine and the carbonyl here would turn into an enamine, and then the weak reducing agent would change that into an amine, so that ultimately we would end up with the molecule we wanted. Now, it might at first glance seem like there's also a third way to make this. So far, we've looked at this molecule, we've said, okay, I can break the bond between the carbon and nitrogen in the top left and the top right. How about in the bottom? Well, if you do that and you erase that, you'll notice that you can't draw a carbonyl on that carbon. That was usually your first step. If you try to do that here, this carbon has 5 bonds on it. It would have 2, 4, 6, 8, 10 electrons around it. That's not possible. It only has an s orbital, 1 s orbital, and 3 p orbitals. Each of those can hold 2 electrons, so it can hold a maximum of 8 electrons. So this cannot happen, and so you wouldn't be able to break that bond in order to do a reductive amination to make this molecule. So in this video, we've done some retrosynthesis. Starting with the product, we've thought of an amine. We've thought of what reactants we would need in order to do a reductive amination. Hopefully this video has given you a clearer sense, or at least a more practiced sense, of how you can combine an aldehyde and a ketone with an amine in the presence of catalytic acid and sodium cyanoborohydride to make an amine.